My name is Paige Yang, and I'm from National Taiwan University. And I'm honored to be here today under the guidance of my advisor, Dr. Yang Fukuo, to share my research on wood species identification using deep learning and light art. Okay. Taiwan has abundant forest resources with various wood species that serve distinct purposes and have a significant price variation, as we can see on the table. And to maximize the utility of timber and prevent economic losses caused by misidentification, accurate identification is a crucial and fundamental step for the utility of wood. And in Taiwan, wood identification plays a crucial role in several areas, especially in illegal logging investigation, and it is also vital for managing driftwood removal because according to the forest regulations in Taiwan, these large amounts of driftwood must be cleared and marked within a month. So the fast and efficient wood identification method is essential. And it is also very important in timber trading to bring in trading method legal standards. However, conventionally, the species of wood logs were identified manually through a series of histological treatments and microscopic examinations, or through sensory methods like smell, color, and texture. However, these manual approaches present several challenges. They are time-consuming and they rely on subjective judgment, and it faces a shortage of experts. So alternative method for wood identification is needed. This research proposed an automatic wood identification system for timely and objective identification. And in my research, I gathered wood cross-section images to train a deep learning model and to achieve real-time identification. The model is deployed on a cloud service platform, and user can access our service. Just use instant messaging application line. And let's start with image collection and the deep learning model. And in this research, a total of 41 commonly found wood species in Taiwan were collected, including 12 valuable wood species, along with 9 commonly misrepresented with these valuable wood species, and 20 economic wood species were collected. And the wood sample were primarily collected from the herbarium at Taiwan Forestry Research Institute. And to attain clear wood grain, a manual surface scraping of the wood sample's cross-section were carried out using a razor. And we use two different ways to collect images. This is first dataset, scan pages. We choose use scanner is because it can provide clear images and can collect rapidly to build our dataset. And a total of about 140,000 scan pages were collected, and with 80% for training, 20% for our model validation. And this is the second dataset, smartphone images. And the purpose to collect smartphone images is to reflect the real-world application scenarios. And the smartphone we use for building our testing dataset is Samsung S-Cover 6, which are the devices used by Taiwan's forest rangers. And a total of about 18,000 scan pages were collected in this research. And we applied data augmentation before training. And we choose Vision Transformer Base as our deep learning model. Vision Transformer Base is a transformer encoder deep learning model. And it pre-trained on ImageNet 21,000 and fine-tuned on ImageNet 1,000. And because of self-attention, Vision Transformer Base excels in capturing global context. And let's talk about how my chatbot works. We first convert our model into Onyx format and deploy on the Triton inference server to ensure stable model inference. And we then utilize chatbot controller Flask for communication between line and our deep learning model. And the total accuracy on scan pages is 94.1, and model performs good performance in most species. However, in the cross-section of certain software species, there are some areas with few distinguished features. These features is likely to misidentification, and misidentification also occurred in some related species during certain growth periods. And misidentification also occurred in some images have severe scratches caused by minimal surface scraping. And the accuracy on smartphone images is about 85%, and the performance, we can see there is a gap between the performance of smartphone images and scan pages. One of the reasons is because blurry images are those who with severe flash are more prone to misidentification. And however, the primary reason for lower accuracy is because the tone difference between smartphone images and scan pages. Even for the same species, color variations still exist. So I also compared the performance of RGB and grayscale images across different models for both scanner and smartphone images. As we can see for scan pages, RGB consistently outperforms grayscale, proving that retaining color information enhances accuracy. However, when it comes to smartphone, the performance of RGB is worse than grayscale, likely due to the severe color discrepancy between smartphone images and scan pages. This brings us to the key challenge is color tone differences between the smartphone images and scanner pages. So our future work is one to address this issue. We propose incorporating a color calibration module into this pre-processing stage for smartphone images, which will help align the color tones between different image sources. And we plan to use the SRI color checker for color calibration because each pages on the board reflect light uniformly and color reproduction process. And we plan to collect the color pages RGB values on both scanner and smartphone. And we calculate and use quadratic linear regression to create a color calibration model to correcting color discrepancies between the two sources. Okay, and this is the demo of our live chatbot, and users can upload the cross-section images, and the live bot will reply 3 probability species within 3 seconds. For those who want to know more information, and this is the top 3 highest probability species. And for those who want to get more information about the wood, we also provide a link to the forest product technology platform in Taiwan. And to sum up, the proposed system provides the frontline personnel with a more efficient and objective method for wood identification. And last, I would like to acknowledge the Taiwan Forestry Research Institute for their assistance in image collection. Thanks for listening.
Let me move on the discussion. Are there any questions or comments? Please.
Thank you for your presentation. I have one question. So you just use the sample of the wood, so just wood block, so identified by smartphone. But if you apply this application system to the real wood identification, so always cutting intersection area is very, very rough and not smooth. So it is necessary to prepare for some smoothing or flattening or everything. So how do you think to the preparation need to the smoothing?
You mean, thanks for your question. Do you mean how to ensure the smooth surface?
Yeah.
Okay. In our training data, we also use manually scraping on the cross-section of wood specimen, and we also collect the real driftwood from different forest institute in Taiwan. And indeed, the procedure to scrape the surface is very difficult. So we try to collect more different ways, scraping method with specimen to try to enhance the robustness of our model. Yes. Thank you.
Any other question or comments? Please.
Okay, thank you for the presentation. So I would like to know, because I feel like the scope of the research is only for the wood block. I wonder if it's possible to improve them into because I like to do survival kind of thing. So basically when we go to the woods, we might want to know what kind of wood it is. Is it possible for us to have a sample of the wood and then using your app to identify what wood is it? Is that possible?
Sorry, I can get the.
Okay.
So,
Sorry.
Okay. So what I'm saying is for example, right now you kind of scope is you have a wood block, right? So you have to get the inside of the wood. Can we try to when we go up inside the forest, for example, we want to identify the wood, and then for survival maybe oh, I want to see this what kind of wood it is. Can we just crack the wood and then try to use it as a sample for your program? Thank you.
I see. In our research, we just need to have 1 centimeter times 1 centimeters range in the cross sections of wood lots. So our application scenarios will primarily in the driftwood removal, and it can easily to get cross section images. Then other sections other surface.
Yeah, thank you.
Did I answer the question?
Sort of, yes.
Thank you.
Unfortunately, the time is up. Thank you.